So today I will be presenting a focus analysis on two-year damage in the blast furnace operation and a structured mitigation strategy to enhance campaign life and operational stability. This topic is critical because two-year failure is not just a maintenance issue, it directly impacts productivity, fuel efficiency, and furnace safety. So let me begin by setting the context and defining the problem we are addressing. Now, tear damage is one of the most frequent and disruptive issue in blast furnace operation. Repeated tear failures lead to unplanned shutdowns, productivity loss, increased maintenance cost, risk of hearth and tear stock damage. Operational data indicate that tear burning is often localized and repetitive, suggesting underlying process imbalance rather than random failure. So, to solve this effectively, we must first understand the root cause behind the tear damage. The key driver of the tear damage can uh, be categorized into thermal, chemical, and and operational rather. And we are talking about the factors which are high raceway flame temperature is one of that is due to uh, imbalance in PCI or oxygen enrichment, incomplete char burnout leading to localized carbon accumulation, alkali and zinc circulation, weakening tuer copper integrity, burden distribution issues causing asymmetric gas flow, hot metal and slag attack, especially under unstable hearth condition in most cases. Tear burning is not isolated, it reflects deeper furnace instability. Now that we understand the causes, and let us examine how these factors manifest operationally. So, from operational observation, um, tear damage typically shows pattern such as higher burning frequency on a specific furnace quadrant, correlation with increased PCI rate without proportional oxygen enrichment, fluctuating tear temperature and raceway adiabatic flame temperature, increased coke degradation near tear zone. These indicators helps us move from reactive maintenance to predictive diagnostic. So based on this insight, we can now define a structured mitigation strategy. And in this slide, we have this mitigation strategy. So mitigation approach must be multidimensional. Process optimization, maintain optimal PCI oxygen balance, control RAFT within safe limit, ensure uniform burden distribution, thermal control, stabilizes flame temperature, improve char burnout efficiency, material and design improvement, use high quality tuer copper with better cooling design, monitor tuer cooling water parameters, operational disciplines. So real time monitoring of tuer temperature, early detection through thermal imaging and data analysis. The focus should shift from firefighting to prevention. So with these measures in place, let's look at the expected benefit that is visible in this slide. So, so coming to those, mm, so by implementing this integrated approach, we can achieve significant reduction in two-year burning frequency, improve blast stability, higher PCI injection capability without risk. So extended campaign life of two-year and hearth. And in conclusion, tear damage is not a merely hardware issue. It's a reflection of process discipline, controlling the furnace, thermodynamics, and flow distribution